Remember that this 6.94 is how much we go out on the x value. Negative 8.27 is how much we go out on the y. 247 is how much we've gone up. So 247 is how tall that cylinder is. And so we went from 0 to 247, which means my height is 247. So if I put this all together for my volume, that's pi times radius squared times 247. I'm going to leave it in terms of pi because I know that this is not the last time I'm going to use this number. I'm going to use this number later on for my total volume. So I'm going to leave it in terms of pi so that way it's easier to use my exact value. Volume 2, slightly more difficult. We still need a radius and we still need a height. So this new guy over here, as we talked about, it's not on an axis. And so it's a little bit more difficult to find in terms of the radius, right? So if we were to talk about that radius, and we've got like your x and y going through, right? If that's our x and y going through, then we went out some direction, which is our x value, and then left some direction, which is our y value, and we got this point. So out on the x, left on the y, and notice that the radius then would be here. So in order to find the radius, I need to complete the Pythagorean theorem. My x value is 6.94. My y value is negative 8.27, and that just means the negative told me which direction I was going 8.27, right? To the left, I went 8.27, but the length is still a positive value of 8.27. So if I do the Pythagorean theorem, I know that r squared will be equal to this guy squared plus this guy squared. So I'm just going to do the square root of 6.94 squared plus 8.27 squared. Because this guy would be equal. So I just took the square root already. That gets me an approximate value of 10.8 of my radius. So for this guy, I have a radius of about 10.8. Remember that since we're using this value later on and we're doing a lot of like, I'm going to use this value later on, that the importance of using exact values is crucial here. So please make sure that you actually calculate this in your calculator and have it available so you're not plugging 10.88 in later on when I ask you questions. Because if you round it here, it's going to get skewed and skewed and skewed, and your answer at the end won't be the same. So make sure that you're always using exact values when you've got a long, complicated process that involves an ultimate idea in which you're taking multiple pieces to plug in. The height. So the height of our next cylinder, we went from 247 to the top of this guy, 258. So if we went from 247 to 258, go ahead and tell me what the height is. All you need to do is subtract these two guys, and you get 11. 11 meters is the height of that second cylinder. So now I just get to plug it all in, put it all together. I'm going to leave it in terms of pi, and if you re-square this guy, you actually get a decimal that's not too bad. And so it is exactly 128.1215 pi. I recommend you retrying to calculate that. Did you get this value here? Did you take this thing that you got from the square root over here and square it again and then multiply it by 11? And did you get this value? And then you just leave pi on there like it's a variable. Leaving it in terms of pi makes it exact, which means you're not rounding in the middle of a problem, which means it won't affect your answers later on. The third volume. I would like for you to try and find the radius of our third cylinder on your own. Okay, So thinking about that circle with the X and Y axes going through it, that we went 5.91 in this direction, and then we went 4.13 in that direction. And so then the radius will be the right triangle that comes out of that. So I can redraw that, but we did X, Y, we did 5.91 in this direction, and then 4.13 in that direction, and then the radius would be like that. So radius and to 3 sig figs, you should get approximately 7.21. Now we save that value in our calculator because we're going to have to use it again to find the volume of this guy, so we can go up and press enter on that. But I'm going to write down 7.21 on my paper so I can remind myself, oh, it's that number in my calculator that's like 7.21 something, something, something. The height. See if you can find the height on this next guy on your own. This one tripped me up for a bit because I saw that the height for the next guy is 279. 258 subtracted from that results in 21. And then I was like, that cylinder does not look like it's 21 compared to this cylinder being 11. Just realize that these guys will never be actually drawn to scale. And so just go back and double check 279, 258. Those are the numbers that they wrote there. And so that has to be the height. Even though it doesn't look like it, it's not going to be drawn to scale. Almost never. Okay, now that we have all of those pieces, I can put it all together, and I want to leave it in exact form. So again, I just write out all those decimals and leave it in terms of pi. I would like for you to try doing this whole dang cylinder on your own. Little hint, this one's nice because you are on an axis. So if you're finding the radius, if we didn't go out on X at all and we only went out to here, how would you find your radius? Okay, so if we only go out to here and we don't go out on the X at all, which is what the 0 for this coordinate means, 0 then 0.6 means that my radius is just 0.6. So that's pretty nice that it was already just given to us because like our first radius, it was on an axis. To find my height, I do 309 minus 279 and I get a height of 30. Because we're leaving our answers right now in terms of pi, you would get an answer of 10.8 pi. So probably one of our easier ones that we've found so far. All right. Then the last thing we have to do is we need to put it all together. And this is where at any point during this process, if we lose track of what we're doing, it's important to have the idea of what we're doing at the very top. Okay, I need to find the volumes of all 4 of those guys. Once I do that, I then add them all together to get my total volume. Having that reminder up top, this type of moment is where it's really important to have that. So you take all of those guys, the exact values, and you add them up. You get about 14,475.22. And so to 3 sig figs, that's 14,500 meters cubed. 3 sig figs. All right, this one is challenging for sure, but definitely possible. On an IB question test question, they would probably break it down for you. They would probably say, find the volume of the first one, the second one, the third one, and then that way you could get follow-through points. Would probably be a nicer way that the IB problem would break it down. But it's possible that a figure of this much complication, a figure that has 3D geometry in it or 3D coordinates, 3D graphing, is possible. Just remember that your coordinates are always just X, Y, Z. And so then that can help you kind of figure it all out.